Okay, if I remember, I think we were shifting the points for example 5b. Okay, so what was it? Left 2 and then down 1. We haven't gone down 1 yet. So left 2, down, oh yeah, we did do that one. So left 2, down 1, and that goes there. And now we're ready to graph. Draw a graph through those. And the graph needs to be approaching the asymptote and going through those 2 points. So the domain is from -2 to infinity, right? And the range is -infinity to +infinity. Okay. So if you want to try the U-try, press pause, see if you can do it, and then take a look at my work here. All right, moving on to example 6. Find the domain of the function without graphing. All right, so if you think about this function here in terms of the base being 2, and we're plotting the point 1, 0, just like we would of the parent function here, log base 2 of x, okay? So the 2 points that we would use would be 1, 0, and then 2, 1. If we plotted those 2 points and we have the vertical asymptote here, you can see it gives you kind of an idea about what the graph looks like and what the domain of the function is going to be. So it's everything above 0. However, we've got a shift going on here. So if I just solve here and say -x is greater than 5, that makes x less than 5. That means that now our graph is on the other side of that asymptote. It's going to be from -infinity, and we have a new asymptote at 5. So there we go. There's your domain. For B, same question. You're asked to find the domain. So we've got a couple points that we're going to have to take a look at. We're going to have to take a look at where the denominator is, where we've got an undefined value. So if an undefined value in the denominator makes us take a look at the value 1, and then also -1 from the numerator. So I went ahead and plotted those on my graph, and I'm going to use a number line to kind of get an idea about what the graph looks like. So if I were to plug in something below -1, so if I put in like a -2, for example, okay, and this is in my head, right? I'm doing 1 plus -2 over 1 minus -2. What's going to happen is it doesn't really matter what the numbers are, but the signs of the numbers are really important, okay? This is going to end up being, the numerator is going to end up being negative, and then this is 1 plus 2 that ends up being positive, right? So usually I put that here, and then the sign of the entire interval right up here. So that's going to be a negative value, because a negative divided by positive is a negative. Well, what happens if we put in a value between -1 and 1? Now, I like 0, so let's try 0. We end up with a positive value in the numerator over a positive value in the denominator. So I'll put that right here. That makes the sign of that entire expression there positive. And then we might have it, we've got another turning point here. We've got an asymptote at 1, so we don't know which direction the graph is going on the other side of this 1. So let's go ahead and plug a number in, like 2, something above 1. 1 plus 2, that's going to be positive, over 1 minus 2, that's going to be negative. So this is a positive over a negative. That makes that interval negative. And the question is asking, find the domain. So the domain's going to be anywhere between -1 and 1. So let me go ahead and graph that, or write that down, between -1. Oops. So basically, this number here is only positive between -1 and 1. So that's your domain. And here's why. Okay. Just take a look right here, what I wrote here. Okay. If you have a log base 10 to, of some negative number, what does that mean? If you rewrote that as an exponential function, 10 to the what number equals negative 2. Well, what number can I put in there to make 10 to that number equal negative 2? There's no exponent that we can raise 10 to get a negative number. So as soon as we saw that negative, boom, we're going to have no graph there. That's the only place we're having a graph, from here to here. All right, let's move on to C. So the absolute value of x is always greater than 0 because the absolute value is the distance away from 0, and distance is always positive. So the absolute value of x is always greater than 0 unless x equals 0. Therefore, x can't be equal to 0. So we just have to put everything in there to make the statement true except for 0. So right there, there's your domain. All right, so now we are going to solve the logarithm equation by rewriting the equation. Okay, so let's go ahead and do that. Start by rewriting it. 3 to the second power equals 4x minus 7. Well, man, that makes that a lot easier. Now all we got to do is solve the problem. So that's a 9 equals 4x minus 7. And that just ends up being x equals 4. And then, of course, you'd want to check it. You want to plug it in and say log base 3 of 4 times 4, minus 7. Okay, we're good. It's greater than 0. All right, so... All right. All right, so here is B quickly done. If you rewrite this as an exponential, x squared equals 64, you'll see x can be 8. If you write plus or minus, you'll see it's negative 8 is extraneous because you can't have a negative base, and I kind of just went over that. For the last one, the last you try, you need a TI-84 because we've got a natural log base here, and log base E, if you look on your calculator, it's just written L, and they usually write the L in lowercase like that. So everyone knows it's an L and not a 1, because if you write this, people are like, oh, is that a 1? So usually when we write ln, we write the L like that. So if you see natural log, it just means the same thing as log base E of that number. So natural log of 5 equals 2x. So, well, I mean, we're going to have to just solve this. And this is an actual number. So, and we're isolating x. So we basically divide both sides by 2. Break out your calculator, type this Jones in right there, and you'll get a value. And that's your answer. Last two, I'll show you the U-tries. Wow, I'm saying quite a lot. 5 squared equals all that stuff. This one's nice because when you throw everything to the same side, you end up getting x squared plus x minus 21, and you're like, great, I can factor it. No, you can't. If you can't factor, you either have to complete the square. Usually I like to do quadratic formula. So that's negative b plus or minus square root of b squared, which is always positive. B squared is always positive. So if b is a negative number and you square it, it's going to be positive. B squared minus 4 times a times c all over 2a. So you just throw those numbers in and you see what you get. And in this case, you end up getting 2 different values, 4.11 and negative 5.11. And just make sure you plug them into the original equation up here and make sure they work. And that is all. Peace out.